Can water boil at room temperature without applying heat? My name is Elliot Wiseman, Instructional Assistant and Tool Room Attendant with the Vancouver Island University Refrigeration and Air Conditioning Mechanics Program. Why is boiling water at room temperature crucial in the refrigeration trade? In refrigeration systems, all air and moisture needs to be removed prior to charging with refrigerant. If not removed, the non-condensables and moisture will cause system failure. For this demonstration, a temperature sensor is strapped to a glass bottle which is partially filled with tap water. Note the sensor in the outline on the slide. When the temperature sensor is initially strapped to the glass bottle, the surface temperature is 64.9 degrees Fahrenheit or 18.3 degrees Celsius. There is a refrigeration hose connected to a stopper with an access fitting on the top of the bottle. The far end of the hose is attached to a two-stage vacuum pump. A compound gauge reads the pressure at the outlet of the bottle stopper. The gauge reads 0 pounds of pressure gauge, which is 14.7 pounds of pressure absolute. The vacuum pump is now running. Observe the pressure gauge indicator needle in the video. The vacuum pump has changed the pressure inside the bottle. Instead of reading atmospheric pressure, it is close to 0 pounds per square inch absolute pressure. The vacuum pump has been running for several minutes. Note the vapor bubbles forming on the bottom of the bottle. The water is now lightly boiling. This chart shows the boiling temperature of water at and below standard atmospheric pressure. Note the blue outlined box. At 64 degrees Fahrenheit or 18 degrees Celsius, water will start to boil at 0.95 psia. Another pressure scale we use in the trade is microns. The micron gauge is connected to a refrigeration system while we run a vacuum pump to remove the air and moisture. The corresponding micron rating is 15,240 to boil water at 64 degrees Fahrenheit or 18 degrees centigrade. The boiling point of water also changes with altitude, due to a reduction in atmospheric pressure as altitude increases. This chart shows a drop in the boiling point of water as altitude increases. Mount Everest, at 8,848 meters, or 29,000 feet, has a boiling temperature of 72 degrees Celsius at the top, not 100 degrees Celsius as we would have at standard atmospheric pressure. The vacuum pump has removed more pressure, causing the water to boil at a faster rate, as the boiling temperature is significantly lower than the room temperature. Thank you for watching this video. These are the references for the boiling point of water on Mount Everest, the boiling point of water versus altitude, and the boiling point of water versus vacuum.